In this example, we're going to use the factor theorem. The factor theorem relates factors and solutions. So we are given two factors here, x minus 2 and x plus 1 are both factors of a given cubic expression, and we're asked to find the values of a and b. Well, if we have a factor x minus 2, what's the related solution? Well, the related solution is the x value that would make that equal 0. 2 minus 2 equals 0. The related root or solution is x equals 2. You should be familiar with this idea already from solving quadratic equations. However, in the factor theorem, we know that if we sub in this root into the expression, the value of the expression will be 0. So f of 2 will be 0. So we're going to take our given cubic and replace x with 2. So we have a times 2 cubed plus 3 times 2 squared minus 9 times 2 plus b. And this must all equal 0. So now I'm going to evaluate and simplify this expression. And we see that 8a plus b is equal to 6. So this is the first linear equation that we have that will help us solve a and b. We now do the same thing with our second factor, which is x plus 1. The related root to the factor x plus 1 will be x equals negative 1. In other words, negative 1 plus 1 equals 0. This is the value of x that would make the factor equal 0. So we're going to get f of negative 1 because the output there will be 0. F of negative 1 is 0 according to the factor theorem. So we'll sub in negative 1 instead of x into our given expression. And this must all equal 0. So I'm going to simplify what we have here. We see we get negative a plus b is equal to negative 12, or a minus b is equal to 12. So now we have two equations. I'm going to solve these simultaneous equations using the elimination method to find the values of a and b. If we add b to a, we will see that the b's will be eliminated, giving us 9a is equal to 18, therefore a must be equal to 2. Sub this value back into maybe equation b is the easier one, so 2 minus b is equal to 12, minus b is equal to 10, so b is negative 10.